Hey guys, so for our film we chose Death Proof, which was released in 2007, directed by Quentin Tarantino. The names of us are Melody Zhang, Crystal Chen, and Victoria Young.
A car filled with four girls of different masses is driving east for 1200 seconds at a speed of 27.77 meters per second east. And car B, with one man, is driving west for 1200 seconds at a speed of 22.22 meters per second west. After 1200 seconds of both of them driving, they crash into each other. Here's the movie clip.
So based on this film and this clip, we decided that we would analyze the contact force when the two cars collide. So in order to figure this out with accuracy, the following variables will have to be determined. The overall net force when the cars collide, the overall acceleration of the two cars when they collide, the time it took for the cars to drive, the acceleration of both cars on the x-axis, the velocity of both cars, the mass of the cars, including the people inside, both of the cars' applied forces acting on the x-axis, the masses of the people in each car, as well as the coefficient of friction, which would be rubber on asphalt.
The variables determined from the clip itself would be the number of cars, which is 2. The timestamp would be 0.02. The number of people in each car, 4 people in car A and 1 person in car B. You can't see the number of people in each car in our clip, but it is visible at the timestamp 0.31 and 0.48 of this link. Here's the YouTube link. Yeah.
Variables determined from research. Both of the cars are 1406 kilograms, and they're the 1970 Chevy Nova and 1969 Dodge Charger. Quentin, which is in car B, is 90 kilograms. Vanessa in car A is 54 kilograms. Zoe in car A is 55 kilograms. Rose in car A is 52 kilograms. Sydney in car A is 55 kilograms. Car A speed is 100 kilometers per hour, and car B's speed is 80 kilometers per hour. The time for both cars are 20 minutes or 1200 seconds. And the kinetic coefficient, which is rubber on asphalt, is 0.68.
Also, something to note would be for the car speed we wrote over here in our calculations we converted 100 kilometers per hour and 80 kilometers per hour into meters per second. Here are our sources of the information regarding the masses and the variables and stuff.
So here is the first part of our calculations that we did. Based on the masses of the people in each car, we found the total mass of car A to be 1622 kilograms, and car B would be 1,496 kilograms. So we decided to use the kinematics equations, and this means that we would have to assume the cars were traveling with a constant acceleration, which may not be realistic in real life. But anyways, we know that the time it took for the cars to collide was 1200 seconds. We assumed the initial velocity is 0. We converted the velocities we found into meters per second, and therefore we solved for the acceleration of each car. So for car A, the acceleration was 0.023 meters per second squared east, and for car B, it was 0.0185 meters per second squared in the west direction. So we can see that car A was traveling at a faster speed or acceleration than car B. And based on that, we solve for the net force of each car. And to the left, you can see the free body diagrams. And we know that the two forces acting on each car are its applied force as well as the force of friction of the rubber tires against the ground. So F net equals the sum of all forces in the x direction. So for car A, we multiplied the mass by its acceleration, and then we calculated the force of friction, which would be the kinetic friction coefficient, 0.68, multiplied by its mass times the gravitational field strength of Earth. And once we solved for applied force, we found it to be 10,846 newtons. For car B, we did the same calculations, and we found the applied force to be 9,997 newtons in the west direction. After that, we drew a global diagram of both cars. So their combined mass is 3,118 kilograms. And then because we already calculated friction, we just subtracted the two net forces of the cars, and the magnitude of car A's applied force was greater, and therefore the net force of both the cars during the collision was 849 newtons in the east direction.
So after we solved for the net force when the two cars collide, we are able to solve for the contact force. So first, we were able to solve for the net force, which basically lets us solve for the acceleration when they collide, because based on our global diagram, when the two cars are together, the mass would be 3,118 kilograms. So basically, F net equals mass times acceleration. The F net, which was calculated previously, which would be equal to the mass of the two cars when they're together times the acceleration. So based on the calculations, we got an overall acceleration of 0.272443874 meters per second square east. And then we were able to solve for the contact force based on both of the cars, which is equal and opposite in direction. So first we used car A, which is a mass of 1,622 kilograms, the force of contact going in the west direction, and the applied force, which is going in the east direction, and then the acceleration, which we already know. And then after that, we are able to solve for contact force with the applied force subtracting the contact force, which is equal to the mass of car A times the acceleration. And then after all of that, we got a force contact of 10,404.59 newtons in the west direction. And this value should be the same for when we use car B, but then in the opposite direction. So the mass of car B, which is 1,496 kilograms, the force of contact, which is going in the right or the east direction, and then the applied force, which is going in the west direction, which is 9,997.02 newtons. So we know that the acceleration based on our global diagram. So the force of contact, which is going east, subtracting the applied force, which is going west, which would be equal to the mass, which is car B's mass, times the acceleration, and then the force of contact, which is 10,404.59 going east. So in conclusion, the contact force when the cars collide is 10,404.59 and then 606 newtons, which is equal and opposite in direction. And when we round it to 4 significant digits in scientific notation, it is 10.40 times 10 to the power of 3 newtons.
Okay, conclusion. When the two cars collide, the contact force is 10,404.59606 newtons, equal and opposite in direction. The overall net force of the collision is 849.28 newtons east. None of the people were seen wearing seatbelts. Based on our contact force we determined and some research, we came to a conclusion that they will propel east. The 4 girls from car A will die, meanwhile the man from car B will also die. We assume that there's no air resistance in our calculations, and if we assume that the acceleration is constant based on the information we had access to. That's the link.
So here's a little bit more about the research we did. And we found that over 50% of passengers killed in car crashes were not wearing seatbelts, just like the girls in the movie. 75% of passengers driving at speeds of over 70 kilometers per hour have died during car crashes. Because our passengers in the movie were not wearing seatbelts and were driving at velocities much above 70 kilometers per hour, we can assume that all the passengers died. In the movie, they show us the 4 girls getting severe injuries, but the movie did not show us the man getting injured. We only see his car getting bounced around on the road, but based on our calculations and research, it is clear that he is also dead.
Thank you for watching our presentation.